Students, it's Miss Green again. We're going to start, this is day 2 of 5-3. So we're going to do a little more with the square roots, the cubic roots, and the biggest thing is we want to be able to look at a graph and see if we can figure out the function from the graph. So before we do that, I want us to look at this function right here. Now notice I could leave the square root of 2 under there, but I think 4, right, is a perfect square, 4 times 3. So I could rewrite that, and that's kind of what we were doing in the last section. We could rewrite that. Let me get the pencil going here. We could rewrite -2, and then we could rewrite 4 times the square root of 3x, and then plus 4. So I know I can simplify that, and I would get -4 square root of 3. And I'm going to actually separate that out a little bit too, just to look at it a little differently. So here's my parent function is the square root of x. And what have I done to it? Well, I've multiplied it by a number bigger than 1. So that gives me that vertical stretch. And then I'm not adding anything to it, so I'm not going left or right, but I am shifting it up 4 units. And then notice this negative sign. That's going to give me a reflection. And it's going to reflect across this k here. It's going to reflect across y equals 4. And you could graph that just to verify that you've done that correctly. So that's kind of interesting. Now we've got a cubic function, and we want to compare this function to the parent function. Well, okay, I've graphed a few points here. I'm going to go ahead and graph the parent function, 0, 0, 1, 1, 8, 2, I remember those, and then -1, -1, -8, -2. And again, you could put that in Desmos or your calculator to just verify, but it looks kind of like this. So if I wanted to look at, well, first of all, the point of symmetry is 0, 0, right? So that means I haven't shifted it up or down. So when I look at this, this is 0 and this is 0. So I'm left with, I'm multiplying that function by something. How do I find that something? We did this a long time ago with, I think we did it with quadratics, and you probably did it with linear a couple years ago. So I know it's a times the square root of x equals y, but I don't know what that a is. So I do know 1x and 1y, and I'm going to use the positive ones just because I like that better. So when I put 1 in for x and 2 in for y, I can start to do some simplification. I can figure out what a is. Well, the cubic root of 1 is just 1, so 1a is just a. So I've got a equal to 2. Now I can go back to my original function up here and put 2 in there, and I could rewrite it. F of x or y equals 2 cubic root of x. And this helps me because if I want to put 8 in here, in my new one, and I do this cubic root of that, I would get 2. 2 times 2 is 4. Sure enough, I can see that it is that. I kind of like to verify things when I start changing them. So that works out good. I want you to try these two. I know this is the square root function because of the way it's shaped. And there's something else you can fill in right away. Whatever this point is, you can put that in. So this would be -5, minus a -5, sorry. And then this is plus a negative 4. So I might rewrite that a little bit. So a square root of x plus 5 minus 4 equals y. That gets you started. Now I just need to find an a value. So you don't need to put every point in, just one point. Don't use this one though, because that'll just get you 0 here, and that's not going to help you a whole lot. So use one of these other 2 points. And then when you look at this one, this is the cubic root of something. Now the point of symmetry, this is my h and k here. So try that one and see what you get. And then stop the video, and when you come back, let's see how we're doing. Radical function, the square root, I found my h and k, and then the nice part here is when I put in -1, -2, this is the one I chose to do, I got a perfect square, so it made my math really easy, and I ended up with a equal to 1, which is nice, because then I don't really multiply it by anything. By 1 doesn't change anything. So I end up with this function right here. Now, the cubic one was a little trickier. It was a little more challenging. Stretch those brain cells, get them working. So I started out, this point of symmetry is 0, -2. So that's my h and k. So I put that in right here. Now x minus 0 is just plain old x, so you don't really need to change it. So I went ahead and put 2 in for x, and then 0 in for y, and I got this lovely little thing right here. So that's the a times the cubed root of 2 minus 2 equals 8. So I added 2 to both sides. Okay, now I'm stuck with the square root of 2, the cubed root of 2 times a equals 2. Remember that if we want to get rid of that, we can cube both sides. We did this too a little bit. And when we cube both sides, the a is cubed, and then the cubed root of 2 cubed would be just 2. And 2 cubed over here is 8. So then I would simplify and say a cubed equals 4. Then I would take the cubed root of both sides and say a is the cubed root of 4. Then I went over here and I wrote it cubed root of 4 for a, then the cubed root of x, and then the minus 2. Well, the cubed root of 4 and the cubed root of x, they have the same index, so I can combine them underneath and just say it's the cubed root of 4x minus 2. Remember how we talked about, so if I leave it under the radical, it's a horizontal compression. It's moving horizontally, getting closer and closer than the original one would be to the y-axis. Or if I put it outside, this is greater than 1, then it's stretching it up, so it's moving it farther and farther away from what would be this line right here. So it just depends upon, if you leave it underneath, it's a compression horizontally. If you put it outside the radical, even though it does have a radical, it's a number greater than 1, then you call that a vertical stretch. Let's look at this one. This one's another example, and I'm going to just kind of help you through this one a little bit. They didn't give us this point, but -8, 4 is that point of symmetry. So that's my h and that's my k. And then I would pick a point like 0, 12 for my x and my y. Now I know I have a square root of, oh, square root? No, this is a cubic. That's a cubic. Of x minus a -8, so it's x plus 8 plus 4 equals y. So here's my h and here's my k. Now I'm going to put 0 in for x and 12 in for y. So a cubic root of 8, because 0 plus 8 is 8, plus 4 equals 12. Nice part here is that the cubic root of 8 is a 2. So a times 2 is the same thing as 2 times a. I'm going to go ahead and subtract the 4 from both sides. And notice this is a little cleaner and neater than that last one, because divide both by 2, I would get a equal to 4. Then I go back and put it into this one. So f of x, or y, is equal to 4 times the cubic root of x plus 8, and then the plus 4 is outside. So that's a challenge, but you want to be able to do that. Here's a application program. So I thought this was kind of interesting, how if you're on the seashore and you're closer to the seabed, or the sea level here, right here, where the water comes up, and as you went higher and higher up the cliff, you could see farther and farther away. So I thought that was kind of interesting. So the visibility, and we're assuming it's a pretty nice day, from a certain spot on a cliff can be calculated using this function. D of x, the distance that I can see, is the square root of 1.5 times x. So x is the height that I am above sea level. So right here, she's 5 feet above sea level, and over here she'd be 40 feet above sea level. And we can see from the function that as her height above sea level increases, so does her visibility as far as she can see. So that's kind of cool. So she's starting at 5 feet and going to 40 feet. So we can see here that we're going to have a minimum and a maximum value for y. And that's what it asks. The distance that she can see is the y. So to get an exact value, you would put in for x 5, that would be your smallest, and you'd do the square root of 1.5 times 5, because that's your x. And when you do that on your calculator, you make sure you put it in the right order and don't do the square root of 1.5 and then multiply that by x. Make sure you're multiplying the product by x. This would be 7.5, square root of 7.5, and it's about 2.74 miles that she could see. That would be the minimum. And then when she went up to the 40 foot above the sea there, you would do the square root of 1.5 times 40. And once again, you want to make sure you do that first, and then take the square root of it. And then she'll be able to see 7.75 miles. That's a nice little distance there. I want you to try this using a similar formula. It looks like the same formula, because her brother did it, but he started at 8 feet above the ocean and then went to 48 feet above. See what his minimum and maximum would be. We got something like this. Again, this is not difficult in just plugging in. You just have to make sure you put it in your calculator correctly so that you get the 1.5 times 8 first. You want to make sure you get that, and then the square root. And some calculators, when you're typing square root, they might just keep it all under the radical, but you're going to have to watch it. Here's another trick you could do. You could do 1.5 times 8, find out what that is, and then raise it to the 1/2. You could do that too. So that's the up arrow 1/2. Remember doing that? Same thing with the other one. So different ways. This is the summary of everything we've done for the last 2 days. And you'll want this in your notes if you don't have it already. There's some good examples here. You could stop the video and look at it. You should be able to recognize quickly that this is some sort of square root function and this is some sort of cubic function here. And you should be able to recognize what happens when the a is 2 and what happens when the a is 1/3. And the h and k here are changing. How does that affect the graph? You'll want some things like that. So take a look. This just says function here. You probably can't see that, the parent function. Take a close look at that, and then we're going to do a little short summary problem and see how we do on this. All right, I want to know, my essential question was, how can I use what I know about transformations to graph radical functions? So I could just plug in a bunch of points and do it that way. But I want to kind of verify that I know that I'm getting some things right here. So is it a stretch or compression? Well, a cubic root of x minus h plus k. So a is less than 1 but greater than 0, so I know that it would be a compression by 1/2. And this, because it's outside, it would be a vertical compression. What about the horizontal shift? Is it going left or right? Well, there's nothing there after the x, so there's none there. The vertical shift is whatever the k is, so that goes up 1. And so we want to know what the graph would look like on here. And here's my function. I do know that 0, 1 is going to be an important. This is a cubic root, so this would be my point of symmetry. I do know it's going to be compressed a little bit, so I'm just going to put some numbers in here and see what happens. I'll make me a little chart. And I'll put 0 in and 1, because that's easy to find the cubic root. And then the other one would be 8. I'll put that in there and see what happens. So when x is 0, 0 times 1/2 is 0. So y would be 1. When x is 1, this would be 1.5. And when x is 8, that would be 2 times 1/2 is 1 plus 1 is 2. Okay, and then I might go ahead and try the negative 1 in there too, because that would give me a negative. That would be, so if I put negative 1 in here, comes out negative 1, 1 minus would be 0.5. And then I might go ahead and put a negative 8 in there too. And that'd give me 2, negative 2 times 1/2 is negative 1. That'd give me a 0. Okay. So I can go ahead and graph some of those points. Negative 8, 0 would be here. 0, 1 is my point of symmetry. Negative 1.5 would be right here. So 1 would be 1.5. That makes sense. And then 8 would be up to here. So you can see how skinny it is. That means it is compressed. And it will increase a little bit. That's not a very good drawing, but you can kind of, and it will eventually get negative. When x is big enough, it'll eventually give you a negative number. Or small enough, sorry. All right, so hopefully you can do that. You might also want to recall the domain is all real numbers. So negative infinity to positive infinity. And then the range, it's a cubic, so that's all reals also. Same thing, negative infinity to positive infinity. There's a point of symmetry. It is increasing. No asymptote. Okay. Have fun with the Math Excel.